Well, without plants, there's no food. And without diversity among our crop plants, the future of food is precarious. Providing ample and nutritious food for a growing human population faces the inexorable challenge of a changing climate. All our crops are also in an evolutionary arms race with pests and pathogens. Dr. Crane will review the importance of crop diversity and the many ways it is being saved and used, drawing in part on the celebration of crop diversity included in the ASBA exhibition Abundant Future.
Sir Peter Crane is president of the Oak Spring Garden Foundation in Virginia. He joined Oak Spring after 7 years as dean of the Yale University School of Forestry and Environmental Studies, the Yale Environmental School. In addition to Yale, his career since the early 1980s has included positions at the Field Museum in Chicago, the Royal Botanical Gardens Kew, and the University of Chicago. Peter is a specialist in the diversity of plant life, including its fossil history, evolution, and conservation. He is the most recent recipient of the ASBA James White Service Award for dedication to botanical art. So without further ado, let me introduce Sir Peter Crane.
Wonderful. It's very, very nice to speak with you. And I just want to say what a fantastic presentation that was by Carol, and how really pleased I am to have this opportunity to speak with you this evening. So Jody, Rebecca, Carol, and everyone else involved, many, many thanks indeed. I wanted to start by saying that you heard last night, I think, from one of our Oak Spring Eliza Moore fellows, Jen, and she just gives an example of the variety of art that we are engaged in at Oak Spring. But I'm really pleased by our collaboration with the American Society of Botanical Artists. And I'm sure that many of you already know about this program, but I'm just thrilled to have the opportunity to say a little bit about it. We've just announced our, I'm just trying to reduce this a little. We've just announced our 2025 Botanical Artists in Residence, and we were helped very much in our selection process by our friends at American Society of Botanical Artists. We look forward to welcoming these 6 wonderful artists to Oak Spring a little later this year. And I just wanted to show you a few of the wonderful things that botanical artists have produced that are already in the Oak Spring collection. The Trout Lily by Irina, and this wonderful Willow Oak by Mieko Ishikawa. And you've already seen Carol's fantastic kohlrabi. The library at Oak Spring really does have a wonderful collection of botanical art going back several centuries. For example, these amazing tulips by Van Spondonk, but also more recent 20th century botanical art that Mrs. Mellon commissioned. For example, this catalpa and a sunflower by Margaret Stones. And we also have in the library botanical art by Rory McEwen. These 2 are the only 2 Rory McEwens that the library owns, and these were purchased by Mrs. Mellon in the early 1960s and were actually loaned to the Kennedy White House during the Kennedy administration. And we currently have an exhibit, we're participating in an exhibit organized by the Royal Botanic Gardens Kew on Rory McEwen. And as many of you will know, he was really just an extraordinary botanical artist. And that exhibit is currently at the Four Arts Club in Palm Beach, and it'll travel to Chicago in the spring. But I want to talk today about the importance of crop diversity in a changing world. And as Jody said, I mean, without plants, there's no food. And without diversity among our crop plants, the future of food is precarious. And I'm just so thrilled that this is a topic that the American Society of Botanical Artists have taken up. And you're going to hear from a real expert on May 18th in this area, Colin Coury, who I know very well, and he'll be speaking at the May 18th proceedings. We were also thrilled to host Abundant Future at the Oak Spring Garden Foundation. And while we don't have a huge number of visitors, not like a major botanical garden, we did have a very, very good reception to this amazing exhibit. And I'm going to draw on some of the art that was included in Abundant Future in the course of this talk. And just to start off, this amazing painting of the variety of eggplants by Jean Emmons, and one that you've already seen, this fantastic rendering of these amazing rice varieties that was included in Abundant Future. And Akito's wonderful black soybeans, and this heirloom tomato. And those of you who grow heirloom tomatoes will know that they taste quite different from the tomatoes that you buy in the store. And we certainly grow them at Oak Spring on our biocultural conservation farm. Before I really dive into the topic, I just want to tell you a little bit about my own background and how I came to be involved in this whole issue of crop diversity. And that really goes back to my time at the Royal Botanic Gardens Kew, when one of the tasks was to get the Millennium Seed Bank going, a project that aimed to collect 25,000 species of plants and conserve their seeds in the seed bank. This was an enormous project. It involved partners in many countries, and I just want to see if I can. Involved partners in many countries, 96 countries, and there are now almost 40,000 different taxa, different plant taxa represented in the Millennium Seed Bank collections. And when I left Kew in 2006, okay, we have a slight problem. When I left Kew in 2006, I was asked to join the board of the Crop Trust. And the Crop Trust, I think largely on the basis of that experience with the Millennium Seed Bank. And the Crop Trust is dedicated to making sure that crop diversity is protected. And I served on that board, including as chair, for quite a number of years, 2 full terms. And so while I'm not an expert in crop diversity, the background that I have comes from my exposure to this world, this very interesting world, through the Crop Trust. And very early in my time at Oak Spring, we hosted a meeting for the Crop Trust at the time that the project on crop wild relatives that I'll speak about a little later was just getting going. And I think that that was one of the ways that Abundant Future was born. And using this quote from Sally in the beginning of Abundant Future, it was really at least an influence in how this topic was chosen for the Abundant Future project. So I'll just say a little bit about Oak Spring. We're really a legacy of Rachel Lambert Mellon, and she passed away in 2014. And I had the opportunity, working with this group, to visit Oak Spring and to think about how it might be utilized in the future. Mr. Mellon had a real passion for horses and art, and his impact on the National Gallery, the Yale Center for British Art, and so on, is well known. Mrs. Mellon had a passion for plants and gardens. And so as we thought about what the future of Oak Spring should look like, and as we thought about stewarding the legacies of Rachel Lambert Mellon, we really thought that we wanted to have a foundation that was focused on plants, gardens, and landscapes. And we thought that this was also a very relevant topic because, as I like to say, no one can opt out of their fundamental dependence on photosynthesis, and plants are crucial ecologically, and they're important regulators in global climate processes. And I think we do have a particular relationship with plants. We have a moral, ethical, and spiritual relationship with the natural world, often manifested in our relationship with plants. And while we certainly have the ability to cut down a 3,000-year-old tree, the real question, I think, is, should we cut down a 3,000-year-old tree? So as we thought about how the Oak Spring Garden Foundation should function, we decided it would focus on plants, gardens, and landscapes, the history and future of plants, botanical garden and landscape art, gardens and horticultural practice, plants and human well-being. And really this topic of crop diversity touches on all of these areas. And we do a variety of activities, residencies, fellowships, conferences, exhibits, and so on. And I think it's very important that we all take the opportunity, whenever we can, to try to convince people that plants are relevant and that the world is really changing before our eyes. When my parents were born, there were 2 billion of us on the planet. And when I was born, we were a little over 2, heading towards 3. When my kids were born, we were over 4 billion. And today we're over 8 billion. And that impact, that growing population, has an enormous impact in the world. But it's not only the people, it's the consumption of that large number of people, which is increasing, which also has a massive impact. And we're moving plants and goods and services around the world in a way that was previously unimaginable. And if we look at how consumption is distributed, we find that it's distributed extremely unevenly. The developed world undergoing most of the consumption, and the global south relatively less. So the way I look at the world is, there are some non-negotiable megatrends that I just can't see us turning around. The global population is increasing and urbanizing. The population in the developed world is slowing. Consumption is increasing. International competition is intensifying, and the drivers of environmental change are strengthening, and change will continue into the foreseeable future. And one of the ways that that is manifested is through the impact of agriculture. And basically, we're using a huge proportion of the Earth's surface area now for agriculture. We've used most of the easily accessible land, and there's a real competition between agriculture and the conservation of natural habitats. So when one thinks broadly about the threats to the future of plants, the threats to the future of plants are really linked to land use change. So, and the major driver of land use change is agriculture. So we end up in a very interesting situation where the future of plants is really linked to how we use them in agriculture. So the challenge of sustainable food production is that we've got to feed that growing population. We need greater agricultural productivity, but ideally we would need it from less land, and we'd need it using fewer inputs, fertilizer, water, and so on. And this is made even more challenging. This task is made even more challenging by the ongoing threats to crops from pests and pathogens and the ongoing disruption of climate change. And we've seen what happens when we base our utilization of our most important food plants on a relatively narrow genetic base. The story of the potato blight is a very clear example. First recognized in North America in 1843, then recognized in Europe in 1845, appearing in Ireland in September 1845, and within a few years, as Olmsted and Rhodes say, roughly 1 million Irish were dead and another 1 million had emigrated. So it's interesting to think about the chain of causation. A crop disease imported to Europe from the Americas, attacking a plant that itself was introduced by the Americas, induced a massive flow of population in the opposite direction. So plants, in this case, were involved through this biological incident, as you might call it, in driving the whole process of globalization. And I love this illustration by Lizzie Sanders that was included in the Abundant Future exhibit, where she shows the cultivated potato. She shows a wild species, Solanum demissum. And it's interesting because this is a spontaneously occurring hybrid between the cultivated potato and this wild species that occurs in Mexico. And it turns out that this hybrid proves to be very resistant to late blight. Phytophthora infestans, the cause of the rot of a potato. And so it highlights the importance of genetic variety for counteracting some of the problems that arise from this arms race that all of our crop plants are involved in with pests and pathogens. So by utilizing the variety of wild species and increasing the diversity in the cultivated potato gene pool, we can start to look for resistant varieties. And this is indeed what happened. The European cultivated potato was on a very narrow genetic base, and important efforts were made to expand that genetic base and create resistance to the Phytophthora. The process of diversification, of domestication, is, I think, an interesting one to reflect upon. You start with a wild species of Solanum, and you end up with a tomato. There are a lot of changes that occur during that process. There's various stages of selection for different properties and so on. But it's basically a process that involves a progressive loss of genetic diversity, from the diversity that you see in the wild progenitor to less diversity through these genetic bottlenecks in land races, and then even less diversity in the modern varieties. So this slide just illustrates a few statistics on the loss of diversity. And I think we all know, we all reflect on our previous experience, that there once was thousands of different varieties of apple. And today we have available to us, usually in mass agriculture at least, relatively few varieties. And what this essentially means is that we're putting all of our eggs in just a few baskets, and anyone who's managed a financial portfolio will know that the most important thing to do is to spread one's risk. And as we narrow the genetic base of our food crops, we're not putting that principle into practice, and we're increasing our risk by being dependent on just a few varieties. In Botanical Art Worldwide, there's I was happy to see a preview of it, and there's this lovely illustration of this etching of lychee. And I just wanted to show you a couple of things from the Oak Spring Garden Library from the 1770s. Here's an illustration of by English trader called John Bradbury Blake of a lychee that he painted in the early 1770s. And I just wanted to show you the detail that he was doing. These are the flowers drawn life-size and then magnified with his notes. But what's interesting in the context of our current conversation is that he was noticing the different lychee varieties, and he was painting those different varieties. And here are the Chinese names of 4 of the varieties that he recognized. And here he says the Chinese recognize 6 varieties. This is in the 1770s. And he goes on to describe their different characteristics. Well, lychee is a plant that's native to the Pearl River Delta, one of the most rapidly urbanizing areas on the planet. And so conserving those varieties of lychees is an important thing to do in the face of that increased urbanization. Our understanding of crop plant evolution was heavily influenced by this man, Nikolai Vavilov, working in the early days of the Soviet Union, and in 1924 publishing his work on the centers of origin. And what he suggested, based on his fieldwork and incidentally his training in early genetics and an understanding of variation while training in the UK, was that he noticed that there were key areas around the world where plants were domesticated. He pointed to these so-called centers of origin. And one of those, of course, is in the Andes, which is where the potato comes from. And today, a group just outside of Cusco in the so-called Potato Park are working to conserve the variety of potatoes in that landscape, working with the native communities there, trying to keep the variety of potato diversity in situ in the landscapes where it originated, which is an important thing. Dealing with crop plants ex situ is one way that we hope to try to conserve genetic diversity, but keeping that diversity in farmers' fields and the fields of native communities is another very important way. Well, ideas of centers of origin or centers of diversity, as they're usually called now, it's a century later, and we have insights from modern genetics, and the picture's a little more complicated, but the central idea that Vavilov put forward is still valid. If you want to conserve the diversity of specific crops, then you need to go to certain specific areas that are of key importance for those crops. And so if one's interested in potatoes, you really do need to go to the high Andes, which is where that crop originally came from and where the greatest diversity of that crop is likely to be found. And you've seen this illustration already. Carol and I did not coordinate on this, but I think it's a very nice one because it shows the massive changes under domestication that took place between the wild ancestor of corn and the modern corn that we have today. These two are going to be part of the Botanical Art Worldwide project. And here's another one. This was part of the Abundant Future project. It's very similar to the Jimmy Red corn that we grow at Oak Spring. And I thought you might like to see this photograph of the Jimmy Red corn, but also this wonderful rendering by Autumn von Plinsky, which he made, which brings a little life into the picture. One of the things that I want to say about crop plants is people have been moving plants around for millennia. I'll just give you one example. So here are some illustrations from 1656 by a Jesuit priest, Michael Boehm, who traveled to China in 1656. And in his illustrations, what you see there are sweet sop, sour sop, pineapple, pawpaw, cashew. These are all New World plants. So very early, those plants had been moved from the New World to the Old World long before some of the current ideas on what constitutes nation states had really crystallized out. And if we go further back and think about where some of these plants were domesticated, they were moved pretty extensively. Just take pineapple, for example. It's a native plant to Brazil, but was first encountered by Europeans in the Caribbean, where it obviously spread long before European contact. Similarly, corn, domesticated in Mexico, but before European contact, it was already growing in Eastern North America and well down into the Andes. The spread of rice, the spread of wheat, and so on. So people have been moving plants around for millennia, food plants particularly. So that leads us to this idea that crop diversity is really a common heritage of humankind. And that may seem like an unremarkable idea, but it is in fact a really important concept. So this is from a paper that Colin Curry, who will be speaking to you in May, published. And it's a lovely graphic, I think, that shows where the food crops that we all use actually come from. And the conclusion is a very simple one. And that is, we're all using crops from all over the world. So the countries of the world are connected by the crops that they're using, which have come over time from different parts of the planet. This is an interesting a graphic. So around the circle, this is another illustration from a paper by Colin Curry. Around the circle are different geographic areas, and the broader band at the top is the amount of calories consumed in that area, and then the lower little band is the contribution of that part of the world to the global calorific utilization. So you can then join the countries by where their calories are coming from. And if you do that, what you see is this amazing network of plants from different parts of the world being used in other parts of the world in very, very complex ways. So this kind of underlines the idea that crop diversity is a kind of common heritage of humankind. We can't disentangle that web. We're kind of committed to it. We can't suddenly say, okay, because rice didn't originate in the Americas, we're just not going to do rice anymore in the Americas. No, we view these crops as kind of part of humanity's common heritage. However, that's very different from the way that most biological diversity is viewed today in the international regime. The Convention on Biological Diversity, put forward in Rio in 1992, emphasizes the fact that biological diversity is national patrimony, and many countries have a very protective view of their biological diversity. And this clearly wasn't going to work for crop plants. So we have another treaty, the International Treaty on Plant Genetic Resources for Food and Agriculture. And what it aims to do is to make sure that the key plant genetic resources for agriculture will be available to be shared, preserved, evaluated in a multilateral way for plant breeding and scientific and food production purposes. So in a way, the international treaty is kind of an opt-out for a certain number of plants, most important crop plants. They're treated differently than the Convention on Biological Diversity would have them treated. So it recognizes The international treaty recognizes that crop diversity is a common heritage of humankind. It creates this system for multilateral exchange, and the crop trust is part of the funding strategy. And that the conservation of genetic resources, as I mentioned in the Andes, could be occurring in situ by farmers and smallholders, but it can also be occurring ex situ in gene banks. And at a global level, if we go to the Sustainable Development Goals, for example, we see that conserving plant diversity is an important part of Sustainable Development Goal 2.5. By 2020, maintain the genetic diversity of seeds, cultivated plants, including through soundly managed and diversified seed and plant banks at the national, regional, and international level. So it's seen as a contributor to sustainable agriculture and our efforts to eradicate hunger, but to do that sustainably in a sustainable way. So it's important, I think, to recognize that the crop plants that we have are the result of a very, very complex process. So this just shows a kind of breeding tree, if you like, for one variety of wheat, and you can see the complexity of the different crossing relationships that have gone into providing that ultimate wheat product. And that brings us to the question of the Green Revolution and the contribution of Norman Borlaug, who received the Nobel Peace Prize, largely because of his work on improving food self-sufficiency in several different parts of the world, particularly, for example, in Mexico and India. Now, the Green Revolution has not always been well received. On the one hand, it solved an enormously important problem in a hungry world. But on the other hand, it's also attracted many critics. But the point that the criticism largely comes from the inputs that are required. For example, the enormous amount of fertilizer that's used in modern agriculture, the nitrogen in the proteins in our bodies, much of it comes from industrial processes that fix nitrogen and turn it into fertilizer. But it's also very important that a really critical part of the Green Revolution was plant breeding and the changes to plant varieties in all kinds of ways, changing the day length sensitivity, changing the partitioning of nutrients between the grain rather than vegetative. Many of these varieties were dwarf varieties, and also disease resistance. So crop breeding has been really important as we've sought to keep pace, even setting aside the inputs, the fertilizer, the water, as we've sought to keep pace with the growing human population. Plant breeding has been absolutely vital. Now, global food security is not all about food production. There are lots of other things to worry about, for example, food waste, but it's certainly part of the picture. And it's also part of the picture when it comes to these evolutionary arms races that I've mentioned. There's always a new fungal disease. There's always a new insect pest coming. Here's one example of a fungal disease of wheat. Here's another one of southern corn leaf blight. And prior to 1930, we had 1,000 or more different cultivars grown in the US, but in the 70s, we had an enormous outbreak of southern corn leaf blight, and it had a devastating impact on American agriculture. We see the same thing today happening, for example, with citrus greening disease. And part of the answer to getting around those difficulties is plant breeding. And people have been interested in these different varieties of crop plants for a very long time. Back to our friend John Bradbury Blake in Canton in the 1770s, he drew two illustrations of rice. They were enormously detailed. And if you show these to the specialists in rice breeding today, for example, at the International Rice Research Institute in Los Baños in the Philippines, then they can see in these wonderfully accurate and detailed illustrations different features that they themselves look at in distinguishing different rice varieties. So the International Rice Research Institute is very much focused on breeding different rice varieties. In the case of, for example, grassy stunt virus, producing resistant genes and breeding those into the rice varieties that are grown around the world, or looking for rice varieties that are salt tolerant. Soil salinity is a problem in much of the world. Looking for varieties of rice that can withstand unusual kinds of flooding events. That's the role of an organization like the International Rice Research Institute, and the material that they have to work with is basically the variety of rice cultivars and land races that they have available for plant breeding. Now, not all crop plants can be conserved in seed banks. Seed banks only work for seeds that can be dried and stored at low temperatures. And so a different approach has to be taken for plants that have seeds that can't be dried, or where we're using plants that are being cultivated as clones, like potatoes or as cuttings. And so things like potatoes, sweet potato, banana, yam, cassava, taro, some of the things that Carol mentioned, have to be conserved in a different way, a much more expensive and time-intensive way, through cryopreservation in liquid nitrogen. But many of our crop plants can be conserved as seed, and those seed last well in gene banks. And the crop trust is really at the center of the global effort to make sure that crop diversity is maintained and that our food supply is thereby secured for the challenges, against the challenges of the future. So its role is really focused on ex situ conservation, providing sustainable funding through building up an endowment, promoting the availability of collections and sharing information on those collections using databases and so on, and then funding some technical assistance and capacity building. It's an independent organization. It was founded by the Food and Agriculture Organization and the Consultative Group on International Agricultural Research in 2004. Since 2013, it's been headquartered in Bonn, Germany, and it's been building the endowment to provide continuous funding for some of the key collections. So, for example, that endowment now provides ongoing, secure funding for the seed bank part of the International Rice Research Institute in Los Baños in the Philippines. The Crop Trust works with a global system of gene banks, and I just want to say a little bit about these different levels. So there are a small group of international gene banks of the Consultative Group on International Agricultural Research. They're scattered around the world, and their job is to provide genetic diversity to plant breeders around the world, to make that diversity freely available. Then there are national gene banks. Many countries have their own gene banks. And then there's what I'm sure many of you have heard about, the Global Backup Facility at Svalbard. So here are the international gene banks. There's Erie down there in the Philippines, and you'll see the others scattered around the world. And those international collections are huge, and they send out every year 100,000 samples or so to more than 100 countries worldwide for their plant breeding programs. And they're involved in long-term storage of crop plants as seed, safety duplication, that is, they're thinking about where are those samples being preserved, and usually the plan is to have a particular sample conserved in 2 active seed banks and also safety duplicated in Svalbard, that I'll talk about in a moment. They're also involved in regeneration and characterization of those varieties, as well as information management, disease testing, and as I mentioned, distribution. And then there are important national collections too. And an early role of the Crop Trust was to focus on those national collections and really highlight the most important genetic variety in those national collections and get them into the international seed banks and get them properly regenerated and made available for plant breeding around the world. And then finally, I just want to say a little bit about the Svalbard gene bank. So seed banks can be vulnerable to natural disasters, they can be vulnerable to man-made disasters, and they indeed may run into a situation where they have insufficient funding or they just don't have the personnel to conduct their work. So the Svalbard Global Sea Vault in the Arctic, it's as far north as you can fly on any commercial flight, is a vault drilled into the solid rock of the mountain with these 3 major kind of storehouses of seed kept at low humidity and low temperature. And the idea is that it is a black box safety duplication of an enormous number of samples from almost every country in the world. And the idea is that it's a backup. So in Svalbard, they're not doing germination testing. They're not regrowing plants. They're just storing the material there in case it's needed, or in case it's needed because it's been lost in the system somewhere else. So it's funded by the Norwegian government. The Crop Trust is a partner in it, but it's really the Norwegian government who've taken the responsibility for funding and operating this bank. And it's very important to understand the conditions under which people deposit seed into the Svalbard Seed Bank. So there's no transfer of legal ownership. The Svalbard facility can't do anything with it, but part of the deal is that that material is made available elsewhere in the world for breeding research and education. And the seed can only be returned to its owner. And it's up to the owner to consider issues as to whether the seed remains viable or needs regenerating and so on. And that will be done through monitoring the other samples of that particular variety that are operative elsewhere in the global seed bank system. So most of what's backed up is material from the CGIR seed banks, international gene banks, but there's also a significant amount of material from national gene banks. And it gives me the opportunity to show some of the wonderful illustrations that were in Abundant Future of sorghum and Emma wheat. They're among the major holdings in the Svalbard gene bank. These 2 fantastic illustrations that were part of the Abundant Future exhibit, and this one coming up that'll be part of Botanical Art worldwide. And really the use of the Svalbard facility came to the fore when, as a result of the civil war in Syria, the Aleppo seed bank, that's the seed bank of the International Center for Agricultural Research in the Dry Areas, so-called ICARDA, was no longer able to operate. But ICARDA had backed up its seed in Svalbard and was therefore able to retrieve seed from Svalbard and use it to establish new gene banks elsewhere in the Mediterranean region, in Lebanon and in Morocco, so that it could continue to function because it was no longer able to do so in ICARDA. So Svalbard clearly proved its worth there. Finally, I just want to say a little bit about crop wild relatives. The genus Solanum, which includes potato, eggplant, tomato, it's one of the largest genera of all plants. There are more than 1,000 species. This is Sandy Knapp, who's a Solanum specialist, looking at one of the books in the Oak Spring Garden library. And Solanum's well represented in Abundant Future with this wonderful immigrant eggplant. But the diversity of Solanum raises the question of whether some of the other Solanum species might be useful sources of genes for transferring, for plant breeding into potatoes, eggplant, tomatoes, and so on. So the idea of this crop wild relative project was to collect some of those relatives and to get them into cultivation, to get them into pre-breeding so that they could be new resources available for crop breeding. And I just show a couple of examples here, this one on chickpea and this one on rice. And Deborah's illustration of foxtail millet is a very nice one because it includes Ceteria italica, but it also includes two related wild species. So in delivering this project, it really drew upon the resources of the two organizations that I had come to know quite well. One was the Crop Trust with their understanding of plant breeding and so on, and the other was the Millennium Seed Bank with their understanding of how one goes out in the field to collect seed. So what needed to be identified was what should the priorities for this collecting be, and where would people go to get that seed, and then once it came back, then it could feed into the pre-breeding and evaluation processes and also be conserved in gene banks so that those genetic varieties were available. So there was an analysis of where the collecting should take place, required coordination with a large number of partners, that many of which the Millennium Seed Bank had worked with before, and it involved financial support for 12 countries to collect crop wild relatives and to bring them into the international system of exchange. And it required the databasing work that went along with that program. So, for example, a program on carrot pre-breeding, eggplant pre-breeding, and sunflowers. These were all projects that Crop Wild Relative project focused on. So its outputs were newly collected seed to go in the seed bank, some pre-bred lines that were made available to farmers and breeders through those gene banks. It involved capacity building, and it involved production of the data that went with those crop wild relatives. So I just finish by showing these three wonderful illustrations that are in the Abundant Future exhibit, but also in the new exhibit, Botanical Art Worldwide, that's coming up, of grapes. So here is one from Abundant Future. This is Vitis labrusca, which is a North American native grape. One of the grapes, native North American grapes, that was used to breed the Concord grape, and one of the varieties that's been used as a rootstock in Europe for overcoming the phylloxera pest in Europe. Not the most widely used rootstock, but certainly one of them. Beta, this is another grape. This is a winter hardy variety, so an example of the new biological characteristics that can come from breeding. This is a winter hardy variety derived from a selection of what we just saw, Vitis labrusca, and a selection of another North American species, Vitis riparia. And then finally, Norton, a complex hybrid with ancestry that involves both North America and European species, illustrated, that will be part of the Botanical Art Worldwide project. So I think that's all I've got to say. I have 7 minutes left before we're at the end of our 2-hour session. I hope you've enjoyed this tour through some of the issues relating to crop diversity and why it's important. And I think we should all recall that the world is changing extremely rapidly. And unless we pay attention, a great deal of biological diversity will be lost irreparably. And particularly important among that biodiversity is the diversity that relates to our most important crop plants. As Carol showed you, she showed you some examples of plants that are important in different parts of the world, but are not widely used everywhere. We've already focused down from some 400,000 species of plants to use just a very small proportion of them. And now we're using a very small proportion of the genetic diversity in that small proportion of species. And that's not a sustainable path for the future. The world is changing. As the world changes, our crops will have to deal with that changing world. And crop diversity for our plant breeders is one of the most important things we can do to ensure the future of food.